everyone. Surface chemistry. Surface can be rough, smooth. Surface chemistry we basically study on the solid surface. How the gas molecule interact with the solid surface. At the junction of two phases where the molecule interact is called interface. The two phases can be solid gas, solid liquid. Some of examples of surface interaction is corrosion of metals, redox reaction at the surface of electrode, crystallization, heterogeneous catalysis in which reactions takes place at the surface of solid catalyst. Adsorption and absorption are the surface and the bulk properties of the substances. When these ion atoms or molecular species penetrate into the surface of the solid and equally distributed is called as absorption. And adsorption is a case when a solid is exposed to a gas. These gaseous molecules are attracted and retained by the surface of the solid. This phenomena of attracting and retaining atoms, ions, or molecules from the gas, liquid, or solution by the surface of a solid is called adsorption. The substance which get adsorbed on the surface is called the adsorbate, and the surface on which it is adsorbed is known as an adsorbent. Adsorption are of two types: physisorption and chemisorption. In physisorption, the molecules are attracted to the surface simply by the van der Waals forces. These are relatively weak and reversible process. The heat of adsorption is relatively low. It involves the formation of multi-layer of adsorbed molecules. Now come to chemisorption. The molecules are held to the surface by the chemical bonds. It is relatively strong and irreversible process. The heat of adsorption is high. It involves the formation of monolayer of adsorbed molecules. The factors which can affect the rate of adsorptions are nature of the adsorbate, nature of the adsorbent, surface area, temperature of the gas, and pressure of the gas. Now, adsorption isotherm. The adsorption isotherms describes the variation of extent of adsorption of a gas on the surface of solid, which increases in pressure at a constant temperature. Frederick adsorption isotherms describes the variation of the mass of the gas adsorbed per unit mass of the solid with the increase in the pressure of the gas in equilibrium with the solid surface. As we know that with increase in pressure, the extent of adsorption increases. The amount of gas is adsorbed is directly proportional to the pressure at a constant temperature in the case of Friedrich adsorption isotherm. Langmuir adsorption theory assumes that the one adsorption site can adsorb only one gaseous molecule and a monolayer of gaseous molecule is formed on the surface of a solid. The rate of adsorption explained in terms of available vacant site at the surface. BET theory of multi-layer adsorption. Brunner, Emmett and Taylor proposed a theory of multi-layer adsorption. It is known as BET theory. This theory explains the adsorption site can adsorb only gaseous molecule in the first layer. The adsorption of a gas on the surface of a solid forms a multi-layer of a gas molecule on the surface of a solid. The rate of desorption from the first layer is equal to the rate of adsorption on the preceding layers. The enthalpy change during the formation of a first layer is called as the enthalpy of adsorption. After that, the first layer, the enthalpy change is equal to the latent heat of condensation or liquefaction of the gaseous molecule.